This video lesson is about using the segment addition postulate to solve for missing values in a line segment. In our first example, we are using the segment addition postulate to find the length of KL. So if you take a look at our picture, we could see this entire segment is IL, but it contains segments IJ, JK, and KL. And we're given some of the information. We know the length of IJ is 9, the length of JK is 11, and we know the length of the entire segment is 26 units. So the first thing that we want to do, and do make sure you're copying down this example in your notes, we want to make a statement using the segment addition postulate. So the postulate tells us that these smaller segments, so in this case IJ, the sum of the smaller segments is equal to the longer segment. So IJ plus JK plus KL, that must be equal to the entire segment IL. All right, now we just want to fill in the information that we know. So we know the length of IJ is 9. We know the length of JK is 11. We don't know KL yet, so we could replace that with a variable. I'm just going to leave KL in our equation. And we know that's all equal to the entire length, which is 26. All right, now we can go ahead and combine our two constant terms. So 9 and 11 is 20. And you probably know the answer here, but we want to make sure we're using our subtraction property of equality. So we're going to subtract 20 from both sides. And what we're left with is the length of KL. So the length of KL is equal to 6 units. Moving on to example 2. This example is a little more difficult because we are not given a picture, but we're going to draw one. And I'm going to be looking for a picture in your notes as well. We're asked to find the value of x and st. We're given some information that the length rs is represented by 2x plus 5, st by 5x minus 2, and rt is 45 units. So if we go ahead and sketch this, we're going to assume that the s's in both of these expressions are the same. So when I sketch this, if I think about it, s has to be between r and t. And we don't know where in between r and t. So if this is point r, this is point t, we don't know if s is in the middle. We don't know if it's closer to r, closer to t. We're just going to label it. The picture doesn't have to be perfect. All right, we said that the value, the expression that represents the length of rs is 2x plus 5. And the expression that represents the length of st is 5x minus 2. And again, this is just for each segment. We know that the length of the entire segment is 45 units. All right, so again, using the segment addition postulate, it tells us that rs, when we add to that st, so the two smaller segments, that's going to give us the length of the longer segment rt. All right, so if we fill those in with the two expressions we're given, 2x plus 5, we're going to add to that 5x minus 2, and set that equal to the entire length, 45. All right, we can go ahead and combine our variable terms on the left side. So when we add 2x and 5x, we get 7x. And when we combine our constant terms here, we want to be really careful. We have a positive 5, but since 2 over here is being subtracted, we're going to subtract that from 5. I like to just think of it as a negative 2. So we're going to add 5 and negative 2, which is going to give us a positive 3. All right, now we have a pretty simple two-step equation. So we know we're going to subtract 3 from both sides because we're trying to isolate x. We're left with 7x equals 42. And last but not least, we're going to divide both sides by that coefficient of x, 7. So our final answer, or when we solve for x, is that x is equal to 6. All right, so we've found our value for x. The second part of the problem, though, is asking us to solve for the length st. All right, I'm going to make some space for this work. So to find st, really all we're doing now is algebra. We said that in the problem, we're told that the length st can be represented by 5x minus 2. And we already found out that x is equal to 6. So I'm just going to use the substitution property, and I'm going to replace the variable x with the number 6. And now we're just going to keep in mind the order of operations. So 5 times 6 is 30. And then we subtract 30 minus 2 is 28. So the length of our segment ST is 28 units. All right, now in our third example, there's a typo. So if you'll take a look, we're told that y is the midpoint of, and it should say segment XZ. So y is the midpoint of segment XZ, and again, we're given an expression for segment XY and YZ. We're asked to find the value of x and then YZ. This is a lot like our last example. Again, we don't have a picture. The difference here, though, is that we need to know what a midpoint is. So remember that a midpoint is going to be a point that divides a segment into two congruent halves. So in other words, the midpoint is exactly in between, exactly in the middle of, the two endpoints of the segment. So the difference here is that when we go to sketch this, we know that if I have our segment, we said the big segment is XZ, we know that y is going to be exactly in the middle. The other thing we know is that XY and YZ are congruent, or in other words, they're the same length. So because we know they're the same length, we know that we'll be able to set their lengths equal to one another. So let's go ahead again and label this diagram. Make sure you're drawing a diagram in your notes. XY, we said that's going to be represented with the expression 4x plus 7. And YZ is represented with 7x minus 14. So now we're not told the length of XZ. That's okay though, because all we need to know is that y is the midpoint. So we said that xy, that the distance xy, or the length rather, is going to be equal to the length yz, because that's what a midpoint does. It splits up the larger segment into two congruent small segments. So now if we just substitute in those two expressions, so 4x plus 7 is going to have to be equal to 7x minus 14. Okay, so now the rest of this is just algebra. I'm going to combine my like terms, and I'm going to start by subtracting 4x from both sides. The reason I'm subtracting 4x instead of 7x is my personal preference is to have a positive coefficient of x. So 7x minus 4x will give us a positive 3x on the right. The next thing is we'll add 14 to both sides to get rid of this subtraction of 14. And I'm running out of room, so I'm going to have to continue this over here. So 7 plus 14 is 21. And now on the right side of our equation, we have 3x. Lastly, we can divide the coefficient of x, divide by 3 to get x by itself. And we find that 7 is the value of x. Oops. Well, that's a funny looking x, sorry. So we are halfway done, more than halfway done really. We found the value of x. We still need to find the value of yz. But we have that expression. We said that yz is equal to 7x minus 14. So if x is equal to 7, we could just substitute that into our expression. So 7 times 7 minus 14. And then we're just going to use the order of operations, so multiply first. 7 times 7 is 49. We're going to subtract from that 14. All right, and then 49 minus 14, well, 9 minus 4 is going to give us 5. 4 minus 1 gives us 3. So 35 is the length of YZ. You've made it to the end of the lesson. So make sure you have all 3 examples in your notes, and you can always rewatch the video if that's helpful to you.